Hello everyone. Today my topic is harmonic time dependent perturbation theory. In last video I have totally discussed about time dependent perturbation theory and constant perturbation. In this case Hamiltonian depends on the time harmonically. H dash function of position and time is equal to 2h dash function of position cos omega t. This can be written as h dash r e to the power I omega t plus e to the power minus I omega t. Taking time dependent perturbation coefficient ak1t is equal to IH cut inverse 0 to t h dash km e to the power I omega kmt dt. This is the formula has been derived in last video. Now put the value of h dash. So you will get ak1t is equal to this term. Now separating two terms, you will get this. On integrating each term 0 to t to the power I omega plus omega kmt dt, you will get this term. Now assume the kth state is above, then the mth state, then omega km is equal to ek minus em upon h cut, and kth state is above to mth state, so omega km is positive. If omega km is positive, then in first term omega km is positive, then in first term omega km is positive, that means denominator is large, so this term can be neglected and consider only this term. If denominator is large, then the term will be small and second term will be considered this. Now taking e to the power minus I omega minus omega m t by 2 outside of the bracket and converting in sine and cos, you will get this term, where sine I omega minus omega m t by 2 is equal to this. Now taking their mod of square, so you will get this type of expression. Thus the probability of transition from mth to kth state is given by this. Now take second case, if mth state is above the kth state, then omega km is negative, and then we consider only first term and separating into sine and cos, so you will get is equal to this. Thus the probability of transition from kth to mth state is given by this. Now take the condition sin theta upon theta is equal to 1 if theta tends to 0. If we apply in above equation, then omega minus omega kmt by 2 tends to 0, or omega minus omega m is equal to 0. So ek minus em is equal to h cut omega. So probability of transition from m to k state is given by this. Omega minus omega km is equal to 0. The curve has a maximum value, and 2 pi by t curve has a 0 value. 4 pi by t curve has a 0 value. This is the end of my lecture.